Hello class, so today we talked about series and parallel. So we need to start talking about how do we find the resistance in them, because there will be multiple resistors if they are in a series and parallel. So your goals for this video are to recognize series and parallel circuits, know your resistance equations, and be able to solve for R equivalent in series and parallel. Alright, so R equivalent is essentially an equivalent resistor. So the idea for that is when we have a more complicated circuit, such as this in parallel, we don't have to try to solve it for each tiny little resistor when we try to solve our circuit. We can instead just find the equivalent resistor and then use that for Ohm's law. It makes things a lot simpler, because otherwise they're almost impossible. So this equation right here is the R equivalent in parallel, and the R equivalent for series is actually much simpler. It's just add them up exactly as they are, and so on and so forth to however many you have in series. Because what happens is then after you do this circuit and you find R equivalent, you can essentially simplify and say that all of these circuits, you can just essentially call it, there's one, label it as one resistant, and that is your R equivalent after you use the correct equations. Alright, and to show you what I mean, we're going to do lots of practice for these. Alright, so when you are solving, you want to start from the inside, like a Russian nesting doll, I'll show you what I mean, and redraw the circuit each time. For example, this is a series and a parallel circuit. We can say R2 and R3 are in parallel. Notice they share this path. However, both of these are now in series, because no matter which path you take, if you hit R2, you're going to hit R1. If you hit R3, you also have to hit R1. So R2 plus R3 as a unit are in series with R1. So that means we have to solve this first. That's the idea of our Russian nesting doll. You start from the inside and work your way up. So you must first find the equivalent of these. They are in parallel. So we would say the R2 and 3 is equal, or it's 1 over resistance R2 and 3 is equal to 1 over R2 plus 1 over R3. And let's just give them some quick values. Let's just say all of them are 10 ohms to make this simple. They're all 10 ohm resistors. So that means we get 1 over R2 plus 3 is equal to 1 over 10 plus 1 over 10. Of course, this is in ohms. That would be 2 over 10, or 2 over 5. Excuse me, that's not right. I jumped ahead of myself. It's 2 over 10, which is equal to 1 over 5. And then now just flip them both over. So now we have R2 plus 3 is equal to 5 ohms. So then when you redraw this, you now have your R1 is still here. This is now your R2 and 3. And we now know this is a 5 ohm resistor and this is a 10 ohm resistor. And now these are in series. So now you just get to add them. So the R equivalent would equal 5 ohm plus 10 ohms, which would give you 15 ohms total. So if you were to then redraw this, it would just be R equivalent total, this is all of them, is equal to 15 ohms, and then you could solve your circuit from there. So I'm now going to present a harder one for you to try on your own. Alright, so pause it, try it on your own, and then come back for a detailed explanation. Alright, so to start off, you first got to figure out where is your inside, what's happening. So we can see that, oops, wrong color. R1 and R2 are in parallel. I'm just going to shorten that to be R2 and R3 and R4 are also in parallel. And then your R1 and 2 and R3, 4 are going to be in series with each other. So you need to go from the inside out, so you should do each one of your parallels first. So if we're doing our equivalent of 1 and 2, that means it's 1 over, because it is in parallel, 1 over 100 ohms, plus 1 over 250 ohms. So yes, you are going to have to do some fraction work here. Probably the easiest common denominator for these is 500. Make it nice and simple for yourself. So that would be 2 over 500, and this would be 5 times each one of these, so it would be 5 over 500 is equal to 1 over 2. You add these up, you get 7 over 500 is equal to 1 over R1 and 2. You flip these, so you get 500 divided by 7, which is equal to about 71, and I'm just going to round that. So it's going to be 71 ohms is equal to R1 and 2. So if we were to redraw our circuit from here, I'm going to erase a lot of things, so pause it. So if we were now to redraw our circuit, we got that R equivalent. So if we wanted to redraw our circuit with that taken account, we have our 24 volt battery. And this is now 71 ohms, and we still need to figure out what this R equivalent is. So now we're going to go and use this. These are, again, this is R3, R4. These are in parallel, so it's going to be 1 over R3, 4 is equal to 1 over 350 plus 1 over 200. And again, fractions. And it's kind of going to be a big one. You can make a smaller one. I don't really want to provide the extra effort. So it's going to be, if we multiply this by 4, it's definitely going to end up being a full even number. So multiply top and bottom by 4. Get this, and if you want to have 2 times 7 is 14, so 200 times 7 would be 1014. Get 7 on the top. Remember, this is all equal to R3 and 4. Add those, you get 11 over 1400. And then flip them. So that's R3 and 4 is equal to 1400 divided by 11, which is about 127 ohms is equal to our R3 and 4. Again, I'm going to eventually erase all this. So now I'm going to again redraw it. So here's our battery. So we know this is 71 ohms. This we just found is 127 ohms. Then, now they're in series, so we just have to find our total, our equivalent. This is the last thing we have to do. It's you've got to add both your R equivalent, 1 and 2, plus your R equivalent of 3 and 4. And that's 71 ohms plus 127 ohms is equal to your R equivalent. Add those, and that's 198 ohms is your R equivalent. So if you wanted to redraw this, there would now just be one resistor that is 198 ohms, and then you could go on and solve for different Ohm's laws and find your current and find your power. We are going to try one more. So again, try this on your own and then pause it. Alright, so first off, let's just build our little sets. So remember, we got to go from the center. So the first one we got to do is this one. These are in parallel to each other. Then, when we are done with that, we must do this. These are going to be in series to each other. And then this, these are also going to be in series to each other. And then all of this is in parallel to each other. And then last but not least, whatever all of this is in series. So if that seems long, that's why we take it piece by piece and just redraw it each time. So the first thing we got to do is this in parallel. So that's R4 and 5. So R4 and 5 is in parallel, so it's 1 over. So 1 over our 37 ohms plus 1 over 45 ohms. This is a really ugly number to find the lowest common denominator for, so I would just multiply them by each other. 37 times 45 is 1,665. That's probably the fastest way to do this, because those are ugly numbers. Add 35 and 75. You get 82 over this. Then flip both of them. Equals about 20 ohms. So this whole thing in here is 20 ohms. So again, you're going to need a lot of space for these. They are kind of just rambling problems. So then our next thing is, alright, so you redraw it with your 20 ohms replacing it. Alright, and then you have these two in series. So you have in series R2 and 3. So that's equal to 49 plus 51, which hopefully you know is 100 ohms. And actually, you could do these both at the same time if you wanted to, the 20 plus 75 for your additional one in series, because they won't affect each other. So R456 is going to be equal to that 20 ohms plus 75 ohms. So 95 So if you can redraw this, there's that first resistor, and it breaks off. I know, my circuits are really beautiful. So this is 100 up at the top, and then 95 down here, and this is still 80 ohms. Alright, so now we have to solve these two, which are in parallel. So our R equivalent of, this is now 2, 3, 4, 5, and 6, so pretty much all of them, is equal to the 1 over 100 ohms plus 1 over 95 ohms. Again, it's probably easiest just to multiply them by each other. So you get 95 over 9,500 plus 100 over 9,500. Add them up. You're going to get 195 over 9,500 equal to 1 over R 1 through 6 is what I'm going to say now. Flip both of them. So it's equal to divided by 195, which is going to equal 48.7, so you're going to round up to 49 ohms. So again, this whole thing here is 49 ohms. Going to erase this again. And then now if I draw it, I have just your first resistor that we have yet to touch, the 49 resistor that we just solved for, and that is about it. So now these are just in series. So for R equivalent, you can just add, so this is R equivalent of everything now, plus 49, 129 ohms is your R equivalent. So if you were to draw this one last time, oops, probably should have done that in orange, one last time, it would just be one resistor that is 129 ohms. Alright, hopefully this was informative. I would try practice them again on your own, and I will see you Monday, and we'll continue going over this. Oh, and one last thing. Bring a 9-volt battery, or suffer an incredibly horrible pop quiz, which not quite a pop quiz I'm telling you, instead of doing the lab where we'll need the 9-volt battery. If you want to be nice, make friends, make money, I didn't say the last part, bring an extra 9-volt battery, and if you have old lights, bring them. You don't have to write this part, but do remember this part. Alright, see you Monday.